All right, section 8.3 is a pretty big section when it comes to your mathematical knowledge and content. We actually get to touch a little bit of the idea and content area of trigonometry, but we're going to stick within right triangles, and you're going to get to use some buttons on your calculator that you've always seen, but you never got to use, and that's the sine, cosine, and tangent button. Now, if you're not looking at a calculator, if you have a cell phone on you, turn that cell phone sideways into landscape mode, and you should see your calculator give you some more scientific options. You're looking for the buttons that say SIN, COS, and TAN, sine, cosine, and tangent. Those are all abbreviated, but we will be using those today to talk about our trigonometric ratios. So trigonometric ratios are equivalent ratios for their corresponding sides in right triangles. And this is very important. That is right triangles. Right now, with this level of trigonometry, it's only allowed to work in right triangles. So here's a right triangle. The first thing I need to establish with you guys is what we already know, which this is the hypotenuse. A and B have always been legs that we've been able to interchange. Now, we will be looking at these sides from a reference angle. For instance, if I was standing down here, I'm going to draw a little person. My viewpoint would be that this is the opposite side, and this is the adjacent side. Now that would change if this little guy was to move over here. Now this would be opposite, and this would be adjacent. Notice hypotenuse always stays put. So we have to make sure we understand that adjacent and opposite, it all depends on what perspective or what reference angle we are talking about. So what we're saying here for these, we call them trig ratios, is that a sine function, and I'm going to abbreviate that for us. This is how you'll see it in your calculator. A sine function is a ratio that when you take the opposite side and put it over the hypotenuse. Cosine is the ratio of the adjacent side over the hypotenuse. And the tangent is the opposite side over the adjacent side. That's going to be something, since this is the first time out the gate that you guys are learning this, that you're going to have to practice. And here's one of the things that we use It's called SOHCAHTOA. Sine, opposite hypotenuse. Cosine, adjacent hypotenuse. Tangent, opposite adjacent. So basically, we're taking this idea and we're turning it into this acronym. SOHCAHTOA. So SOHCAHTOA. SOHCAHTOA just seems to be a little bit easier to remember, to stick in your head, rolls off the tongue, SOHCAHTOA. And we can use that to then interpret what each of the ratios represents. So what are the sine, cosine, and tangent ratios for angle T? And notice they tell us the reference angle, meaning that's where I would put my little guy. Well, I'm going to put a star for now. So that means the sine is going to be, so sine is SOH, S-O-H. So opposite and hypotenuse. So 8/17. Cosine is CAH, C-A-H, so that's adjacent over hypotenuse. And tangent is opposite over adjacent. Now, they didn't tell us what this angle was. Okay. Eventually, we're going to do it based off of the angle. There we go. All right, moving on. So sine, cosine, tangent ratios for angle G. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. All right. In 1990, the Leaning Tower of Pisa was closed to the public due to safety concerns. The tower reopened in 2001 after a 10-year project to reduce its tilt from vertical. Engineers' efforts were successful and resulted in a tilt of 5 degrees, reduced from 5.5 degrees. Suppose someone drops an object from the tower at a height of 150 feet. How far from the base of the tower will the object land to the nearest foot? So there's the triangle. I'm going to redraw that triangle just because it'll be a little bit easier. So it's a 150-foot drop. This is 5 degrees. We want to know what is x. So why this trig function is so important is we can find missing sides of a right triangle with only having an angle and one side. For the Pythagorean theorem, we would have needed two sides to find a third. Now we can use an angle and a side length. And here's why. Any right triangle that has a 5-degree angle in it, one, we know what the other angle is going to be because this is 90, this is now 95. So we know what this other angle is going to be. Not only that, is it defines now the ratio of all the sides. We just need to know what ratio defines it. Is it sine, cosine, or is it tangent? Well, we have an opposite and we have an adjacent side. So that's going to be tangent. And that's one of the things you're going to have to learn. You're going to have to figure out what ratio should I be using, sine, cosine, or tangent. So tangent, now they give us the actual angle measurement. So in our calculator, if we do tangent of 5 degrees, it will give us an actual ratio. It'll give us a rational number. Now, if you're using a calculator from school or one like it, make sure you guys hit the mode button for me real quick. And that first, you'll see that it should be blinking on normal. Underneath of it, you have the option, actually it's the third row down, to select either radian or degrees. Make sure degrees is highlighted. Mine was not because we're in 5 degrees. If you're on your phone, you should see you have like a DEG or an RAD option. Make sure you're in degree mode. And just to test that, right now, if everybody was to hit the tan button and then enter the number 5, close those parentheses, and hit enter, you get 0.0874886635. So if you have that, you're on the right track. So we know that if you take the tangent of a 5-degree angle, then the ratio of the opposite side to the adjacent side, which is x over 150, we know that this ratio, which we don't know right now, but the calculator knows, the ratio, the tangent ratio of any 5-degree, from any 5-degree angle in a right triangle should be whatever this number I just repeated to you. So this fraction should equal this decimal, no matter what calculator you're using. We should all be getting the same number. Now, before you go ahead and take that decimal and you round it, let's just do some algebra before that. We want to get x by itself, so let's multiply both sides by 150. Those cancel out. So we get x equals 150 times tangent of 5. So in your calculator, you're going to type 150 times, press the tangent button, input the 5, close the parentheses, and you get 13.1, we'll round it to 1, 2. It actually says round to the nearest foot. So 13.12, so x is about 13 feet. So let's practice these now. I want you to first acknowledge which angle that we're looking from, and then what is missing and what is given. I have a hypotenuse, and I have an opposite. So what ratio deals with opposite and hypotenuse? That would be SOH, S-O-H. So that's a sine function. So I'm going to do in my calculator sine of 54. That decimal is going to equal this fraction. So to solve that for W, I'm going to multiply both sides by 17. So that's what W is going to equal. So W equals 17 times sine of 54. So W is about, this says round to the nearest tenth. So 17, you don't even have to put the time symbol in, just type in 17, then put sine right after it. 13.8. Let's look over here. From 28 degrees, we have opposite, and we have adjacent. So that's going to be TOA, opposite, adjacent. So tangent of 28 equals 1 over W. So this time we have the variable on the bottom, which requires an extra step, but really if you think about it, we can just do cross products here, which is W times tangent of 28. There's a couple ways to think of it. And then 1 times 1 is just 1. Now the W is up top. Actually, there's no denominators anymore. So we're going to divide both sides by tangent of 28. Try and remember, tangent of 28 is just a number. We're just carrying it around written like that, so we don't have to round it. That divides away. So W equals 1 over tangent of 28, which is about 1.9. Hypotenuse, adjacent. So I'm dealing with an AH, that's cos. And so TOA, so that's cosine of 33 equals adjacent over hypotenuse, multiply both sides by 4.5. So W equals 4.5 times cosine of 33. So W is about 3.8. One of the first things you guys have to practice is figuring out, should I be using sine, cosine, or tangent? And that's what that SOHCAHTOA is there to remind you of. Okay, you need to get that word SOHCAHTOA, that phrase, kind of stuck in your head. Maybe I'll share some videos with you guys tomorrow to help you do that. You might resent me for sharing those videos because they will really get stuck in your head. But there's some videos out there that are kind of helpful. All right, what is the measure of angle x to the nearest degree? So now we are missing the angle. So if we had angle x, this would be opposite over hypotenuse. So this would be sine of x equals 6 over 10. So now we actually have the ratio. We don't know the angle measure. So we need to get x by itself. So how do you cancel out a sine function? So this would be the same idea of, kind of follow me with this. If I had 2x equals 10, we would do the opposite of multiply by 2. So we would divide by 2. Okay? Follow me there? My tools don't seem to be working like I think they're going to. There we go. If I had x plus 2 equals 10, we would do the opposite, so we would subtract 2. Follow me there. When I say we do the opposite, mathematically what we're saying is we're going to do the inverse function. And that probably goes back to maybe 7th grade for you, maybe earlier, maybe a little bit later. And then one of the things maybe was 8th grade or 9th grade algebra 1 would be, actually I'll write it like this because we just did it in the Pythagorean theorem, right? If a squared, or maybe I should be even more relevant there and say c squared equals 144. How do we get to c by itself? Well, if it's being squared, the opposite of that, or the inverse operation, would be to square root it. So c equals 12. So every time we solve these, we're doing the inverse operations. So to get x by itself, we need an inverse operation of sine. And the way we do that is we write it as inverse sine, and that's what this means. This is not an exponent that you're going to evaluate. This just means inverse function. So I'm going to do inverse sine of both sides. Now it's kind of hard to write it over here, so I'm just going to rewrite this all. Inverse sine function of both sides. And what happens when you take this inverse sine of sine, they cancel each other out and you're just left with x equals the inverse sine of 6 over 10. So what is the inverse sine of 6 over 10? To the nearest degree, well, on your calculator, above the sine button, you'll see inverse sine. So hit second sine, and now you have an inverse sine. And inside of there, put 6 divided by 10, close those parentheses, or 0.6 since it's a nice decimal, but it won't always be. Hit enter, and you get x is, it says to the nearest degree, 37 degrees. So not only can we find missing sides, we can actually find missing angles. Let's try it over here. From x, we have adjacent hypotenuse. So that's going to be cosine of x equals 15 over 20. And you guys will all skip steps whenever you're ready. I'm not going to skip any steps right now. So that cancels out, and we're left with x equals inverse cosine of 15 over 20, which is 41 degrees. So what is the measure of angle y to the nearest degree? Well, we're given adjacent and opposite. So that's going to be a tangent with opposite over adjacent. In the shortcut, if once you get good at this, you'll just say, well, that y is going to equal inverse tangent of 100 over 41. So y is about 68 degrees. That's going to take some practice, okay? Make sure you guys understand that it's okay for that to feel a little unnatural, okay? That's trigonometry. It's the first taste of trigonometry there. So practice that. Make sure you understand the SOHCAHTOA relationship, what it means, and go ahead and take a look at those homework problems. Tune into office hours if you have any questions. Some of you like just to message me or email me, no problem. Okay.